Hello friends and welcome to Free Shiksha. We'll continue our discussion on permutation and combination, and today I'll start the questions based on permutation, which are of two types: when all the items are distinct and when some items are distinct. We'll take the first case in this lecture when you have all the items as distinct, and a very specific case of this, which is the seating arrangement, a very important topic from where many questions comes in multiple choice questions. A typical question looks like this one: in how many ways 7 boys and 7 girls sit in a row? And these are the multiple subparts of this question in which I have divided it. When we'll cover all the 6 parts, you will be a master in solving the seating arrangement kind of problems. So let's not waste any time, and I'll rather move slightly quicker through these problems, as there are 6 cases which I have to cover. So with the first one, when they can sit in any arrangement, you have 7 boys and 7 girls, which makes a total of 14 distinct entities which can sit in any arrangement. So how many ways can they shuffle among themselves? 14 factorial. This is something that I taught you in the very first lecture in permutation and combination basics. So let's move on to the next problem, where you have to make all the boys sit together. So if I consider all the 7 boys as one entity, why so? Because every time you will make an arrangement, these 7 will have to move together. So I have considered all these 7 boys as one entity because they will move together always. And now this makes a total of 8 entities, 7 girls and 1 entity as boys. So how many ways, in how many ways can these 8 entities shuffle? In 8 factorial ways. Now the boys, which will always be together, can shift among themselves, can switch their positions, but only among themselves. So these 7 entities can also shuffle in 7 factorial ways. This makes a total of 8 factorial cross 7 factorial ways when all the boys have to sit together. Third case, when the boys have to sit together and the girls also have to sit together. Very similar to the previous one, just that you will make the entire set of 7 girls also as one entity, and then these 2 entities can shuffle in 2 ways or simply 2 factorial ways, and then boys can shuffle among themselves in 7 factorial ways, and similar is the case for girls, who can shuffle among themselves in 7 factorial ways. So this makes a total of 2 factorial cross 7 factorial cross 7 factorial, which is the answer for this particular case. When the boys and girls are at alternate position. So again you have 2 cases here. When you start with a boy, then these are the possible ways in which the boys and girls can sit. Or you can start with a girl, then followed by a boy, then girl, then boy, a girl. So in both these cases, if we take them separately, the girls can shuffle among themselves in 7 factorial ways, and the boys can switch their places and shuffle in 7 factorial ways. So you have 2 such cases. So this makes a total of 2 into 7 factorial into 7 factorial, which is the answer for this particular problem. Fifth one, which is the most important question, which arises, which you will be able to see in most of the question banks or any practice problems or any examinations also, is when no 2 boys have to sit together. Now when they say no 2 boys have to sit together, what you have to do is make the girls sit first. Let the girls fill the positions, which will be one place, and you'll always leave one place between the girls. This is the way how you solve these questions. So there could be a boy sitting before a girl, there could be a boy sitting after a girl, and you will always leave one position between all these girls. Now these are the 8 places where 7 boys can sit. Now try and understand that if you pick any 7 places from these 8 and make the boys sit there, no boy will sit together. There will be at least one girl who will always be between them. You can pause and have a look. You can select any 7 places and you will always see at least one girl which will be there between the boys. So this is how you have to approach this kind of problem, which is a very important one. When no two boys have to sit together, make the girls sit at positions, make some empty places between them and before and after them, and then let these places be filled by boys. The number of boys could be 5, 4, 3 or anything, but the places you'll create is similar. You'll always create these 8 places when you have 7 girls. So 7 places out of these 8 can be selected in 8C7 ways, and then those 7 boys can shuffle their places in 7 factorial ways, and similar is the case for girls, who can shuffle among themselves in 7 factorial ways, which makes a total equal to 8C7 cross 7 factorial cross 7 factorial. This is a very important question. When all the boys are not together, so this is a very important, very simple case. You simply subtract the case when all the boys were together from the total number of cases. This will give you the answer when all the boys are not together. So these are some similar problems which I would want you guys to solve on your own now that you have covered all the possible cases with seating arrangements, and you should be in a good position to solve these problems. That's it for today. In the next lecture, we'll take some items distinct case, and that is it for today. Thank you so much.